Hello everyone, this is Shankha and welcome to chapter 4 of the Spring tutorial for beginners. So in chapter 3, we talked about the various Spring modules, and in this chapter we're going to talk about the core module of Spring, and the core module deals with inversion of control and dependency injection. So without talking about any theory, we dive straight into some coding and see what IOC and dependency injection are with some examples. And once we're done with the coding bit, we're gonna talk about some theory, right? So the IDE, or the integrated development environment that you see that I'm using here is called STS, and you can download it from the internet for free. And to create a project, you can click on file and then choose new, and if you're trying to create a Spring project, you can click on Spring Start a Project, and you can give the name of the project here. You can give the group ID, artifact ID, the version, the description, and this would be using Maven as a build tool, and this would be packaged as jar. So once you just name the project, and then you can choose the dependencies that you want for your project. And since I've already created a project, to save some time, I won't be selecting any of these, so I just click on cancel. So I've already created a project called IOC demo, and let's open a POM and take a look at the dependencies for this project. So here inside the dependencies tab, we have Spring Boot Starter, so that is going to provide the basic Spring dependencies for a project. And then we have Spring Boot Starter Test, so that is going to provide us with the test dependencies for a project, right? So that is basically it. We don't have any fancy stuff. We don't have any other dependency other than the Spring core dependencies, right? Now let's imagine that we are a service provider, and there's a client for us who uses our code or who uses our application to read data from database. Now the client is not really concerned about how we store our data or what data store we use, whether we use a relational database like Oracle database or MySQL database, or we use some non-relational database such as MongoDB or Cassandra to store our data at the backend, how we fetch the data. The client is not really concerned about all these stuff. What the client wants is the data. What the client wants is when the client sends a request for fetching some data, it should be able to fetch that data. That is all the client is concerned about, right? And our application is responsible for retrieving the data from the backend, from the database, and providing the data to the client, right? So let's try to create an interface, or try to create an application that would provide a connectivity and to the database from the application layer, and that would fetch the data for our client, right? So what I'm going to do is, inside this package com.demo, so let's first take a look at this class that has been generated for us when we created the project. So if I open this up, we have Spring Boot application annotated here. So this would mark this as a Spring Boot project, right? And when we do this string application.run, it is going to run, it is going to do a lot of stuff behind the scenes, and it is going to start the application context for us and do all the fancy stuff behind the scenes, right? So what I'm going to do is I'm going to create an interface and call it database, right? And inside this, I'm going to have a method called boolean connect, right? So this method would be responsible for connecting to the database, and it would return a true if the connection is successful, else it would return a false, right? And let's keep this simple, so I won't be having any more methods inside this, and I would create another interface called relational database database BASE, and this would extend the database. Right, and I would create another interface and call this non-relational database. Right, and this would also extend database. Right, and I would create a class and call this Oracle database, and this would have relational database. This would implement relational database that we just created. Right, and inside this we just print connected to Oracle database. Right, and we'd return a true from here. Right, and let's create another class that implements relational database, and we'd call this MySQL database. Right, and this implements relational database as well. Click on finish, and again we print connected to MySQL database. Right, and we'll return a true from here. Right, now let's create some non-relational databases. So I'd create another class and call it Mongo database, and this would implement non-relational database. Right, and here we would print connected to Mongo database, and we'd return a true from here, and we'd create another class that implements non-relational database, and we'll call it Cassandra, and this would implement non-relational database as well. Click on finish and print connected to Cassandra database. Right, and we'll return true from here. Right, so we have our connections ready. Now let's create a client inside this class. So what I'm going to do is I'm going to say @bean, and I'm going to say public void this, or public void client, and in later chapters we're going to see what this @bean means and what these annotations mean. Right, So for the time being, let's just concentrate on inversion of control and dependency injection, right? So what I'm going to do is I'm going to say private. We're going to create an instance of a database. So I'm going to say database db, right? And we need to create an object of a database, object of a concrete class for the database. So I'd say db equals new, let's say Mongo database, MongoDB, right? And then let's call db dot connect, right? Now let's run this application and see how this works. I'm gonna say run as and Spring Boot app. So we can see we are connected to Mongo database, and this application just works fine. But there's a problem with this application, or there's a problem with this approach. So what we are essentially doing is we are leaving it up to the clients to create an object of our database, right? It is a client who is creating an object of the database, and it is not our application. We as service providers are not creating an object. It is rather the client that is creating an object of the database. And let's suppose in the future we have moved our data from MongoDB to some relational database, or from MongoDB to say Cassandra, which is again a non-relational database. Then it is a client who has to change the code, right? But the client is not responsible, or the client is not really concerned about how we store the data. It is we who have changed the way we store the data. So that has nothing to do with the business requirements of the client, and yet the client has to change the code for it to work, right? So that is not something we would want to do. We'd want to create the object ourselves, and that should be an abstraction to the client. That should be abstract to the client. The client should not be having an idea about how or what kind of database we are using at the backend, or what kind of database we are using to store our data and stuff like that. All the client is concerned about is the data, to fetch the data from the backend, and we should provide an abstraction on how the object is created, and it should not be the responsibility of the client to create an object. It should be rather the responsibility of us as service providers to create an object for the client and present that object to the client so the client can use it, right? So how can we do that? And that is the basic concept of inversion of control. So here the control of creating an object is with the client, right? The control of this object, of creating this object and maintaining the life cycle, maintaining this object, is with the client. So what inversion of control says that what the concept of inversion of control says is it should not be the responsibility of the client to create an object or to maintain an object. It should rather be the responsibility of the service provider to create an object and to maintain the life cycle of that object. So how do we achieve that? So I'll just remove this, the creation of the object, right, in the client code, and I would say auto-wired. Now I'll explain what auto-wired does in a moment. Just for the time being, I'll just mention auto-wired here, and I'll mark these concrete classes as components, right? Just copy this and paste it in other concrete classes as well, right? Now let's try to run this. Now what we did is we removed the responsibility of creating an object from the client, and we placed it with uh, and we moved the responsibility of creating an object to the service provider, which is the application that we're trying to create, right? Now let's run this and see what happens. Okay, so the application fails and we have a message here. And what does it say? Application failed to start. Description: field db incom.demo .ioc demo application required a single bean, but 4 were found: Cassandra, MongoDB, MySQL database, and Oracle database. What does this mean? This means that Spring is actually trying to inject an object. Since we are not creating an object here, since the client is not responsible, no more responsible for creating an object of database class, it is the service provider who is responsible for creating an object which is of type database. And when we say @component, we are telling Spring to create an object of this class when the application context is loaded or when the application context is initialized, right? So Spring would create an object, or Spring would create a bean for all these classes or all these implementing classes. Spring would create a bean, right? Create beans for all these implementing classes. And here, when we say auto-wired, what we are trying to do is we are trying to inject a type which is of database into this variable called db, right? Now we have 4 beans that qualify to be injected into this variable db, because we want Spring to inject a type which is of database, and there are 4 beans which are of type database, namely Oracle database, MySQL database, Mongo database, and Cassandra, right? So these 4 beans qualify to be injected into db, and Spring does not know which bean needs to be injected into this variable, right? So what we can do is, let's suppose our data is inside Mongo database. So we'll mark this as @primary, and we'll save this and we'll run this again. So now we don't get an error, and we can see we are connected to Mongo database, right? And this time the client is not responsible for creating an object. It is the service provider who is responsible for creating an object. Now let's suppose in the future our data has moved from MongoDB to Cassandra, right? So all we need to do is, instead of having the primary annotation here, we just put the primary annotation here. So all this change is happening at the service provider level. The client doesn't get to know about this change. This is the client code. The client code doesn't change. It is a service provider code that changes, and the client doesn't get to know about this change, because the client is not really concerned about how we stored the data, where we stored the data, how we fetch the data. All it is concerned about is getting the right data when it makes a call to our database, or when it makes a call to a service, right? So we don't have any change in our client code. It's only the service provider code that changes, right? Now let's run this again. Say run as Spring Boot app. Now we see we are connected to the Cassandra database, right? So in this example, we have seen how @component works, @primary. Okay, so when we had multiple beans that were qualified to be injected into a particular variable, when we mark one bean as primary, that bean got injected into the variable, when there were multiple beans that were qualified to be injected into a particular variable, right? Now, what if a client specifically wants to use a MySQL database, or it specifically wants to use a certain kind of database? How do we do that? We can do that by doing a simple tweak here. So we'll say @autowired private database, say db1, right? And we'd say @bean, we'd say public void client, let's say Oracle. So this client specifically wants an instance of the Oracle database, or it wants us to store the data in the Oracle database. So what it does is, it does db1.connect, right? Now, since we have Cassandra marked as primary, this db1 bean would also be injected with a bean. This db1 variable would also be injected with a bean, or with an object of Cassandra class, right, or Cassandra database. Let's run this and see if that is true. So I'll just say inside Oracle client, right? I'll run this as a Spring Boot app. So this client also has Cassandra injected into its database type, right, or db1 variable. But this client specifically wants to use Oracle database. So how does it do that? What it can do is, it can just write qualifier on top of this variable and specify the name of the bean that it wants. So it wants Oracle database, right? So it's gonna say Oracle database, right? And let's run this now. So now we can see the second client is connected to Oracle database. So what we just did is, we marked this field with an annotation called qualifier, and inside this we specify the name of the bean which we want this variable to be injected with, right? So when there are multiple beans that are qualified to be injected into a particular type or a particular variable, we can specify which bean. If there's a requirement where we need to inject a bean of a particular type as a client, then we can specify the name of the bean with the help of qualifier annotation, right? What we also could have done is, instead of making this primary, I just remove the annotation primary from this variable, so from this class. So now we have 4 beans again that qualify to be injected into the 2 variables that we have declared here, right? Or into this variable that we have declared here, because this already has qualifier annotated. So what I would do is, I would remove this qualifier annotation. Now all the 4 beans qualify to be injected into these 2 variables, right? And we want to inject, say we want to inject MongoDB into this variable, and we want to inject Cassandra into the, or Oracle into this variable, right? So what we can do is, we can just rename this to, say Mongo database, right? And we just rename this to Oracle database, right? We haven't marked any class as primary, and we haven't specified any qualifier. What we just did is we just changed the name of the variables to Mongo database and Oracle database, right? Now let's run this and see if our application fails or it works. Sorry, I just misspelled this. So it should be database PAC. Let's run this and see if it fails or it works. So it does work. It actually works. We first client is connected to Mongo database, and second client is connected to Oracle database, but we never marked any bean as primary, and all these beans are qualified to be injected into both these variables, right? And we don't have qualifier as well. So what we actually did is we did dependency injection by name. So when the name of this variable is same as that of a qualifying bean, Spring knows that we are trying to do a dependency injection by name, and we are trying to inject a bean which has the same name as this variable. So since Mongo database has a same name as this variable, Spring would inject, if there are multiple beans that qualify to be injected into this variable, Spring would try to find a bean that has the same name as this variable, and if it does find one bean, it will inject that bean into this variable. And similarly for Oracle database, we have a bean named as Oracle database, right? And this is called dependency injection by name. Now what if we just say we removed Cassandra? Let's remove Cassandra. Let's delete this class, right? We have deleted Cassandra. Now there's only one type of non-relational database that we have, and that is Mongo database, right? And let's say we change this database type to non-relational database, and we rename this to, say, DB instead of MongoDB. And let's try to run this again. And see what happens. So this time we don't get an error, and because there is just one bean of non-relational database type that is qualified to be injected into this variable. So that is dependency injection by type. So if there is only one type of object, or there is only one type of bean that qualifies to be injected into a particular variable, then Spring knows that that particular bean has to be injected into the variable, and it does so. So in this example, or in this video, we have seen dependency injection by name, dependency injection by type, and we have also seen the use of @component annotation. We have seen the use of auto-wired annotation. Now let's talk a bit about the theory part of what is inversion of control and what is dependency injection. We have already seen these two in action. So inversion of control is a principle, or is a design. It is basically a design principle which says that the responsibility of creating an object and maintaining the life cycle of an object should not lie with the client. The responsibility should be with the service provider. So that is inversion of control. in the legacy systems, we had this responsibility with the client. It was the responsibility of the client to create an object and then use that object and maintain the life cycle of that object. But inversion of control says, or the design principle of inversion of control says that the responsibility should not be with the client, it should be with the service provider. And that is exactly what we have done here. And dependency injection is a way we can achieve inversion of control. So here, instead of creating an object ourselves, we are telling Spring, we are giving hints to Spring as to how to create object for us and how to maintain those objects, right? So if we are saying that we need this, we need to inject an object of this particular type into this variable, and there's only one qualifying bean, then it will Spring would inject that object or that bean into this variable, and that is called dependency injection by type. And then if there are multiple beans or multiple objects that qualify to be injected into this variable, then we can do a dependency injection by name, right? So that is exactly what we have done here. So if the name of the variable is same as the name of the bean, then Spring would do a dependency injection by name. We can also have a control at the client side as to which dependency we want to inject into a variable, so we can use qualifier for that. If we mention the name of the bean that we need to inject into a variable inside qualifier, Spring would inject that particular bean or a bean with that name, with the same name, into that variable, right? And we can control which bean is injected into a variable at the service provider side as well. So we can annotate our classes or annotate our components as primary, and if there are multiple beans or if there are multiple objects that qualify to be injected, then the primary bean would be given precedence and would get injected into the variable. So that is how dependency injection works, and that is how dependency injection is a way we can achieve that is how dependency injection is a way through which we can achieve inversion of control. So this is all about this chapter, and in the next chapter we'll see the various ways in which we can do dependency injection. There are various ways such as constructor injection, field injection, setter injection, and we talk about the advantages and disadvantages of each of those types. So I hope you guys like this video, and if you did like, give it a thumbs up and stay tuned for chapter 5. Thanks for watching.